Today we started our unit on geometry with lesson 8.1. We're learning about angle relationships and parallel lines. Adjacent angles are side by side and share a common ray, as well as a common vertice. This would be the common vertice. The ray is highlighted in blue. These are all examples of adjacent angles. You can see that the common ray is highlighted in a different color and it is between both angles. These are not adjacent angles. A couple of them have a common vertice, but none of them have a common side. Complementary angles sum to 90 degrees. 90 degrees is equal to a right angle. Complementary angles add up to 90 degrees and can be shown here that it's okay if they're adjacent and complementary, but they don't have to be adjacent. By definition, if two angles are complementary, they add up to 90 degrees. So they do not have to be adjacent to be complementary. That complementary is the key to tell you that the sum is 90 degrees. Supplementary angles add up to 180 degrees. 180 degrees is another name for a straight line or a straight angle. These two angles are adjacent supplementary angles. Here's more examples, and you can see on the right that they don't have to be adjacent. Again, by definition, two angles that are supplementary add up to 180 degrees. Vertical angles are opposite one another, and they are congruent. Congruent means they are equal in every way. When two lines intersect, they form two pairs of vertical angles. You can see here the two angles that are equal to 100 degrees. It's almost as if from the middle point or the point of intersection where the vertex is, it's almost like those two angles kind of are reflection of the other. So it's a little bit easier to tell if you kind of look at it that way. If you were given one angle measure, you could calculate the other three based on the fact that the missing angle is now supplementary to 100 because it forms a straight angle or a straight line, and then the other angle is a vertical angle to that angle. Here they are, 80 degrees. So altogether you had 100 degrees for the other angle and now 80 degrees. You can see that that forms a straight line, and all of them together make up the two pairs of vertical angles. So if we had two parallel lines, L and M, as indicated, the four angles that measure 120 are shown. The angle relationship that they have, if this top one right here is 120, we know the vertical angle is this one right here. We're going to learn more about some angle relationships, but all you need is one angle measure when parallel lines are intersected through a transversal. In this case, it's line N, and you could calculate all the other angles based on their relationships. So the missing angle was 60, and all the angles then are either 60 or 120, and they're related to each other through either vertical angles, supplementary angles. We have corresponding angles, alternate interior and alternate exterior. We'll learn more about these in the coming slides. Here is the diagram of some of the congruent angles. The first one, alternate interior. Those are the angles that are formed inside or interior of the parallel lines. They are alternate, meaning on opposite sides of the transversal. So they're kind of highlighted here in color for you, so you can see the ones that are equal to each other based on that relationship. The pink ones, or peach color, are equal to each other, are congruent, and the blue ones are congruent. In the middle diagram, the alternate exterior angles, again, are forming lines that are equal. So even comparing it to the alternate interior picture, you can see the peach is in the same relative position as a vertical angle that's on the exterior, and that's equal to each other. So exterior, alternate are outside or exterior of the parallel lines, and they are on alternate or opposite sides of the transversal. Remember, the transversal is the line that cuts through or intersects both parallel lines. The corresponding angles in the right diagram shows that as that transversal cuts through the parallel lines, it's basically, I think of it as cutting through at the same angle. So it's forming four corresponding angles. And when I look at the peach angle in this one, and I'm looking at it in the top line, I'm kind of saying, relatively, it's in the upper right corner. That's the angle formed. So there's a corresponding angle as the transversal cuts through the lower parallel line, which is the upper right corner. Then you have your purple. They're equal to each other when the lines are parallel. The blue are also congruent and equal to each other, and the green are equal and congruent. So that's another way for you to help you find all the missing angles when needed. We're going to practice a few. Find the missing angle. The angles are complementary. When we say that the angles are complementary, we know that it means that they are add up to 90 degrees. So therefore, we can take 36 plus this missing angle we'll call x. X would equal 90 degrees. By solving this one-step equation, 90 minus 36 gives us x is equal to 54 degrees. You may check your work because if these two angles are complementary, they will add up to 90 degrees. Take 36 plus 54 to see that they are indeed 90 degrees. Solve for x. Same idea. These two angles are complementary, meaning that their sum is 90 degrees. So we add them up. 3x plus 2x is equal to 90. And if you recall from when we learned about like terms, you can simplify this before solving for x because we've been asked to find x. So 3x plus 2x can be combined because they both have the same variable raised to the same power. So we add the coefficients, or 3 and 2, together and simplify it to 5x. If 5x is equal to 90, we know that 5 times a number equals 90. We can undo the multiplication through division, and we find that x is equal to 18. Now that's not a measure of degrees. It's simply what that variable is. We know that 3 times x, or 3 times 18, would give us the degrees, and then 2 times 18 would give us the other. And if we actually substituted in those values and added together, we would get 90 degrees. For supplementary angles, if we are to find the missing angle, our equation is similar, but a little bit different because supplementary angles total 180. So x plus 168 is equal to 180 degrees. To solve this equation, we would simply subtract 168 from both sides, and we'll get x is equal to 12 degrees. Similar to our last example, these two angles are supplementary, meaning that they add up to 180 degrees. 4x plus 5x equals 180 degrees. Like terms will give us 9x is equal to 180, and we undo multiplication through division. So x is equal to 20. Again, not a measure of degrees, just the value of x. Find the missing angles, and we are given that the one in the upper left is 42 degrees. Therefore, when I start thinking about all these angle relationships, I have vertical angles, I have corresponding angles, I have alternate interior and alternate exterior, and it would be easiest for me to start with finding all the ones that are equivalent to 42 degrees. So I start with my angle B because it is an angle that is vertical to the one given. D is in a corresponding position to the original angle, and it is also alternate interior to the one I just found. And therefore F is 42 degrees. The other angles that are left are all supplementary to the 42 degree angle. So to find A, 42 plus A equals 180. If I subtract 42 from both sides, I will find that it is 138 degrees. So I fill in or else list off to the side if it's not enough room to write all of them. Every other angle through those same relationships with vertical angles, alternate interior, alternate exterior, and corresponding will give us these two measures. And our final example, well, actually it's not, it's our second to last example, to name the angles congruent to angle 3. I would first look at angle 1 because it is vertical to angle 3. Angle 5 is congruent because it is alternate interior, and angle 7 is corresponding. All angles supplementary to number 6, to angle measure 6. Well, looking at angle 6, I see that it is adjacent to angle 5 and also supplementary. So if I'm looking for all angles that are supplementary to angle 6, I need all angles that are equal to angle 5, which are again angle 3, angle 1, and angle 7. If the measure of angle 1 is 105 degrees, what is the measure of angle 3? And through the vertical angle definition, it is equal to 105 degrees. If the measure of angle 5 is 120 degrees, what is the measure of angle 2? Since 5 and 2 are not in any kind of corresponding alternate interior, alternate exterior vertical locations, I know that they are supplementary to each other. And if you can't see that, find something that is equivalent to 5, like we know angle 3 is because of alternate interior, and 3 and 2 are adjacent, therefore supplementary. So we would find 180 minus 120 to give us the measure of angle 2, which is 60. The last example had a ton of work on here, and I know that we went pretty fast in class, so hopefully you're taking your time now, and I'll try to talk a little bit slower. We'll start over here with the angle that we see measured 44 degrees. Okay, that measure is 44 degrees. A couple things that we can look at. J is, so angle J will be equal to 44 because of the fact that it is vertical to the 44 degree angle. Angle K is supplementary to 44. Therefore, supplementary angles add up to 180. So 44 plus K equals 180. Another way to write that is 180 minus 44. So we know that K is 136 degrees. If K is 136 degrees, then C is 136 degrees because of the fact that they are vertical angles. Switching over to this, let's look at this transversal right here. And I can see that angle L and the 63 degree angle at the top, right there, are alternate exterior, therefore L is 63 degrees. Again, we're looking for these relationships. If L is 63 degrees, then I is 63 degrees because of vertical angles. If L and I are 63 degrees, H and A are both supplementary to 63 degrees. So to find the answer, we would subtract 63. So if I go up here to A, 180 minus 63 is 117 degrees. So that's for it's hard to make that little degree sign. That's for angle A, and it's also angle H. 117 degrees. Okay. Moving on. I can tell back here at this transversal that I have that measure 44, and I can see that angle G is in a corresponding position to 44 degrees. So G is equal to 44 degrees. If I know angle G, I know angle E, because angle E is vertical to G. Looking back at this angle, 63 degrees. We talked about that already. I see that its vertical angle is B. So a lot of these are already given, and we just have to determine the relationship. So to find D, well, let's see. I know that D plus E plus 63 will equal 180. So I could take 180 minus 44 minus 63 to find D. And I find that angle D is equal to 73 degrees. If angle D is equal to 73 degrees, then angle F is equal to 73 degrees because those two angles are vertical angles. And that concludes our notes.
That was easy.